Hello students, welcome to Edupharm, a platform for all GPAT and NIPER aspirants. Today's lecture will be on pharmacognosy, especially on the topic of the drug contains glycosides. Many medicinal plants contain glycosides. Glycosides are complex organic compound. If we hydrolyze a glycoside, means if we break down a glycoside molecule, we get one aglycone moiety and another is a glycone moiety. The aglycone part is the non-sugar part and the glycone part is the sugar part. This sugar and the non-sugar moiety join together to form a glycoside molecule. Sugars are most commonly of beta-D-glucose type. So plants contain only beta-glycosides. Always remember that there is no alpha glycoside present in plants. Plants always contain only beta glycosides. Glycosides can be classified by two methods. The first method is based on the type of glycosidic linkage, and the second method is based on the type of aglycone moiety. The linkage between the glycone and aglycone part is known as glycosidic linkage. The glycone and aglycone moiety can be linked together by carbon, oxygen, sulfur or by nitrogen atom. There are four types of glycosidic linkage. The first one is C-glycoside. In this, the glycone part and aglycone part is joined together by a carbon atom. Example of C-glycosides are aloe, cochineal. Second is O-glycoside. The glycone and aglycone part is joined by an oxygen atom. Example of plants which contain O-glycosides are senna and rhubarb. S-glycoside. The glycone and aglycone part is joined together by a sulfur atom. Example of S-glycoside is mustard. The active metabolite of this plant is known as cynigerine. And lastly, the N-glycoside. The glycone and aglycone part are joined by a nitrogen atom. The typical example of N-glycoside is nucleoside, present in DNA or RNA. Deoxyribonucleic acid or ribonucleic acid is example of nucleosides. The second type of classification based on the aglycone moiety. Glycosides have two parts, glycone and aglycone part. The therapeutic value of the medicinal plants containing glycosides are solely based on the aglycone moiety. The aglycone moiety is that compound which gives the medicinal property of the plant. It's not the glycone part. Remember that aglycone moiety is the part of the compound which gives the therapeutic value. And the sugar part, the glycone part, have some values like they absorb the glycosides or they helps in transportation of the aglycone part to the site of action. But the therapeutic value is solely responsible for the aglycone moiety. So aglycone moiety is a very important part of a glycoside compound. So the second method of classification is based on the aglycone moiety. The first one is anthracene or anthraquinone glycosides. Example are senna, rhubarb, aloe, cascara, cochineal. Second, cardiac glycosides or steroid glycosides. They are digitalis, thievesia, squil, strophanthus. Next one is saponin glycosides. Examples are diascorea, zesti, shatavari, brahmi, ginseng, senega, gokru, kuilaya. Then cyanogenetic or cyanophoric glycosides. The examples are bitter almond and wild cherry bark. The next one is isothiocyanate glycosides, example mustard. Then flavonoids, example milk thistle and rutin. Then coumarins, example sodelia. Then aldehyde glycosides, example anantamul. Then phenol glycosides, example barberry. Then steroidal glycoalkaloids, example is solanum, cassinum. And lastly, bitter glycosides, examples are gentian, chirota, quassia and stevia. Note down these plants and the classification as well, because it is observed that in GPAT and NIPER exam there are some questions like they give you the plant name and ask about the type of glycoside or type of glycon moiety. So try to remember the whole classification thoroughly. Some important points. Cascara, a medicinal plant, has both C and O glycoside as active metabolite. C glycosides cannot be hydrolyzed by acid or alkali. C glycoside can only be break down by using ferric chloride. Glycosides and alkaloids are isolated by Stas-Otto method. The Soslet apparatus is using to isolate them from plants. Thanks for watching. If this video is helpful to you, please like and share with your friends, and don't forget to subscribe our channel Edupharm. We have a Facebook page also. Feel free to contact at any time. So stay tuned. We'll be back soon with another lecture. Thank you.